Hello everyone, once again. Welcome to my channel. Please don't forget to subscribe. Today we shall be discussing and calculating different diameters and velocities of fluid flowing through a branching piping system. Once again, we'll be discussing and illustrating how to find velocities, diameters, areas of a fluid piping system branch into two sections. Now, let's read out our question. A pipe conveying water with 30 centimeter diameters branches into two pipes of diameter 20 centimeters and 15 centimeters, respectively. If the average velocity in the 30 centimeter diameter pipe is 2.5 meters per second, find the discharge in this pipe. Also, find the velocity in the 15 centimeter pipe if the average velocity in 20 centimeter diameter is 2 meters per second. Once again, a pipe conveying water with 30 centimeter diameter branches into two pipes of diameters 20 centimeter and 15 centimeter, respectively. If the average velocity in the 30 centimeter diameter pipe is 2.5 meters per second, find the discharge in this pipe. Also, find the velocity in 15 centimeter pipe if the average velocity in 20 centimeter diameter pipe is 2 meters per second. Now, let's illustrate this using our diagram below. We were given a pipe conveying water with diameter 30 centimeter and with velocity 2 meters per second. Now it branches into two. The flowing in the pipe branches to two. Whereas in section 2, we have diameter of 20 centimeter with the velocity flow of the flow, which is 2 meters per second. Also, in section 3, we have diameter of 50 centimeter with unknown velocity, which we are asked to find. Now, let's pull out our parameters. We have our D1 diameter in section 1, which is 30 centimeter, which equals 0.30 meter. We have diameter 2 of pipe 2, which is 20 centimeter, which gives us 0.20 meter. We have diameter 3 which is 50 centimeter, which gives us 0.15 meter. Now, we also have our velocity 1 from pipe 1, which is 2.5 meters per second. We have our velocity 2, which is 2 meters per second. We have our velocity 3 is unknown, which we are asked to find. Now, how do we find it? By using equation of continuity of a fluid mechanism, which equals A1 V1 equals A2 V2, which is our equation of continuity. Now we are asked to find area before we can use it. So we need to find areas of all the pipe system before we can use the continuity. So in so doing, we need to find all the areas. So how do we find it? By using A1, which equals pi D1 squared over 4, which is for area 1. Area 1 equals pi D1 squared over 4, which gives us pi times 0.3 squared over 4, which gives us 0.068 meters cubed. Also, our area 2, pi D2 squared over 4, which gives us pi over 4 times 0.2 squared, which gives us 0.0314 meters squared. Also, we have our area 3 pi d3 squared over 4, which gives us pi times 0.15 squared over 4, which gives us 0.01767 meters squared. Now, we have all our 3 areas being calculated now. Now, the next thing is to slot in all the parameters we've calculated into our equation of continuity. So in so doing, we have, using the continuity equation, Q1, the rate of flow in pipe 1 equals the rate of flow in pipe 2 and plus pipe 3. So Q equals A1 V1 equals A2 V2. Now we are asked to find in our question, don't let us forget, the discharge in the pipe. The discharge in the pipe. So the discharge Q1 in the pipe section 1 equals Q1 equals A1 V1. So don't let us forget, we have our A1, our V1. We give us 0.7068 multiplied by 2.5, which is the velocity, which gives us 0.176 meters cubed per second. Now, we are asked to find in our question 2 that the velocity in the pipe section 3. So, V3 will equals to Q3 over A3. So, how do we find Q3? So, how do we find Q3? Don't let us forget our Q1 equals Q2 plus Q3. So, we need to find our Q2 first. So how do we find our Q2? Q2 equals A2 V2, which equals 0.0314 times 2.0, which gives us 0.0628 meters squared per second. Now, we can now find our Q3 in order to get our formula. Our Q3 equals Q1 minus Q2 from the first equation here. So our equation Q3 will equals Q1 minus Q2 will give us 0.176 minus 0.0628. So we have our Q3, 0.1139 meter cube per second, which is our volumetric flow on section 3. Yeah. So we can now find by using all the calculated entries, we can now find our V3, which we are asked to find, which is the velocity at pipe 3, which equals Q3 over A3, which gives us 0.1139 over 0.01767. So our V3 equals 6.44 meter per second. So the velocity of flow, the average velocity of the fluid in section 3, V3 equals 6.44 meter per second. Thank you very much. Don't let us forget to subscribe. Thank you.